All right. Okay, we're finally set up. So welcome to today. The date is March 21st. If we go down to the bottom of this and go to our syllabus, we can go to March 21st and we can see today. Today is more collections framework stuff. We're going to have a quiz today. Anybody who didn't pick up a bubble sheet when they came in, they're on that air cleaner in the back. Please go get one so that you're ready when it comes time to do the quiz. We're going to talk about most of the same stuff for the next 3 classes. We're going to have 2 review sessions. And then we're going to have a 3rd exam, okay, on all this material. So I hope you will all keep your minds sharp and be ready for that. And I'm also going to try to squeeze in a few more quizzes. I haven't been able to squeeze as many in for various reasons, but we'll try to do better. Okay, any questions before we start? All right. So what I'd like to do today is I'd like to just sort of do some little thought problems. So we know what an iterator is, right? What's an iterator? Who can tell me? Nobody in this room knows what an iterator is? That's bad news for you on your quizzes. Nobody. Not one person knows what it is. Yes. What's your name? What's that? Izol? Zol. Zool. I'm sorry. Can somebody else say it louder so I can hear better? Joel. Jewel. Jewel. Oh, okay. Jewel. Okay. Right. And what is the type of iterator in what package does iterator live in? Who can tell me what package Java, what package iterator lives in? What's that? I still didn't hear you. Util. It's in Java util. And your name, Bo. Okay. I should know that one, but okay. So yes, it's in Java util. Iterator is in Java util. What 2 methods? Okay, what is the iterator? Is it a class? Is it an interface? Is it an abstract class? What is it? Bubble sheets on the air cleaner. I'm sorry, what? Okay, so Brad says it's an interface, and it is. How many methods are there on that interface? Brad says there are 3. Anybody else besides Brad have an opinion about what they might be? JJ, yes. Or what? Well, I'm asking what the methods are. I'm asking what the methods are. Somebody in this room? Yes. I'm sorry? Right, has next. What does it return? A Boolean. Okay. And what's your name? Bennett. Okay, so Bennett says that it has a Boolean has next on it, and that's true. What's another method? So Brad's jumping in and saying next. What type does next return? It is not another Boolean. Yes, it is object. Okay, Logan says it's object. But there is an exception to that. If I don't want it to be object, if I want it to be something else, right, I can put angle brackets and that type. So if I say iterator, angle bracket, integer, close angle bracket, then the next method will return an integer, okay? And so long as that thing in the angle brackets, can I put an int in that angle bracket? Can I say int? No, why not? Why can't I? Int isn't an object. What is it? Right, int is a primitive type, so I can't do that. So what I'd like to do, I have this idea, because we all love Fibonacci, right? Fibonacci is like the best thing ever. What about an iterator that returns the next value in the Fibonacci series every time you call it? And what if that iterator terminates when it hits integer overflow? So it never returns to you a negative number for the Fibonacci. How could we write that? So that's what I thought we might try to work on together here. And now I'm getting into trouble because of this stupid thing. All right, good. Come on. There we go. Fib iter. Now, fib iter should implement or extend. Somebody besides Brad. I know Brad got Vanek. Implements. And Vanek, you know what it should implement? Iterator. You want to put an angle bracket? Yeah. Yes. Yep. And what's your name? Michael. Okay. All right. Now we also have to do an import because it's in util. Okay. So we said that it has two methods on it. We said it had a Boolean has next. Is that right? What's that? We could add override is always optional, but we can put it. Public, right? JJ has put his finger on it, public. So I want public. Okay, and then the other thing I want is public integer next. Now, anybody have any idea how we're going to make this work? I really need your help. I can't figure this out. Michael. Right. Okay, so what I'm going to say, I'm going to make a field, all right? I'm going to say int next, right? And I'm going to say return hat next. Let's call it next val, just so it's a different name than the method. Val greater than 0. All right. So our next val should be greater than 0. And so that means that we have to have our next value pre-computed, right? All right. So what does that tell us? What do I have to do? What else do I need to put in this class to make it work? Well, okay, so how do you compute a Fibonacci number? What? You can use a recursion method, but I mean, just in general, mathematically, what is a Fibonacci number? Right, it's a, what's your name again? Arthur. Okay, so a Fibonacci number, bubble sheet behind you, bubble sheet behind you, bubble sheet behind, yeah. So a Fibonacci number is the sum of the previous two numbers, right? All right. So so what we could do in this class, I'm going to suggest, is we could keep track of those previous two numbers. All right? So we could have int n1, int n2, right? We'd have fields, non-static fields that we're using to keep track of the two previous Fibonacci numbers. Okay, so what's the first Fibonacci number? 0. What's the second Fibonacci number? 1. So let's think about this. 0, 1, 1, 2. We're always building it off the previous two, right? And it would be kind of nice if we could sort of bootstrap this process. So what should I initialize n1 and n2, right? So I guess what I'm saying is, so for my next value, what I want to do is I want to say int return, or int ret, say, equals next val, right? And then I want to say, let's see, n1 equal n2, n2 equal next val, and then next val equal n1 plus n2, right? Because that's how Fibonacci numbers work, right? What should I initialize n1 and n2 to? Chris, n2 should be equal to 1, he says. What about n1? Yes, Drew. Okay, let's yes, that's a good call, Drew. Yes. All right. What should I initialize n1 to? Just somebody give me a suggestion. 0. Okay, I'll just put 0 there. All right, and see what happens. So now we need a main method. So I'm sorry. Let's back up. What do you want to do? Well, what's going to happen, right, when I call next, I'm going to call next val, and then I'm going to say n1 is equal to n2. So I'm going to override n1 immediately, right? So I think it doesn't really matter what we put in n1. Well, yeah, so n2 is going to be, so let's see how this is going to work with things as they are. So I'm going to set n1 to, I'm going to set, what's that? I'm sorry, Scott? Well, next val has to be 0 initially because the first value in the Fibonacci series is 0. Okay, so let's look what happens with our next method when we call it, at the way we've got things now. Okay, so n1 becomes n2, and n2 is 1, okay? And n2 becomes next val, and next val is 0. And then next val becomes 0 plus 1 is 1, which is correct. Okay, so armed with this reasoning, public, what's the next thing? Static, void, main. There are people who don't know this incantation, and you really need to. What's next? String, array, args, All right. And now what we're going to say is for int f in new fib iter system.out.println f. Oh, I didn't make iterable. Sorry. What I should do is fib iter fitter equals new fib iter while fitter dot has next fitter dot next. Fitter almost sounds like it should be a rapper name, right? Like Fitty, and I don't know. I forgot the return statement. Dope. Homer Simpson. Have you never watched The Simpsons? Spider Pig does whatever a spider pig does. Look at that. 0, 1, 1, 2, 3, 5, 8, 13, 21, blah, blah, blah. And then oh, sorry. Awful cough. We did it. We made it. We made a Fibonacci iterator. Drew. Yep. Yes. Yes, because 0 is the first Fibonacci number. It's kind of cool the way that works out, right? That iterator. All right. So more Fibonacci. I'm going to make a class called FibMap. And in this class, I'm going to make, I'm not going to make a non-standard, a non-static. I'm going to say public int fib int n, right? And I'm going to say, I'm going to write the thing that we always do. Right? I'm going to write that same logic that we always wrote. But what I want to do is I want to make this work differently. I want to so we know that calculating a Fibonacci number can be expensive, right? We know that Fibonacci number can be expensive. So maybe if we ask for the same one, could we have a little less talking, please? Thanks. So maybe if we're going to calculate the same one again, right, we want to optimize that. So we don't want to have to keep recomputing the same Fibonacci number each time we call it. So in this case, what you're thinking of is the Fibonacci calculation. You're thinking of it as a proxy for some more complicated calculation. So how could I optimize, calling Fibonacci? So let's set this up like this way. Okay, so public static void main string args. All right, and I'm going to say fib map fm. Okay, so now I'm going to have a loop, and I'm going to say for int I equals 0, I less than 10, I plus plus, system.out.println, fm.fib 20. All right, so I've got this code, and it's going to call fib 20 10 times in a row. And it's just going to calculate the same thing over and over again. And yes, that was fairly fast, but I could just pick a bigger number and make it not fast. But the point is we'd like to avoid doing redundant work, right? We'd like to somehow save our result. We know we've called fib20 already. We'd like to not have to recompute it every time we call that with the same value. Anybody have a thought how we could make that happen? I could, and so what I've done, right, is I've made this not static, particularly because I wanted to store a value in my fib map. So I'll call it fib cache. I'll set it to -1 initially, and I'll say if, and then int last n equal -1. All right, so if n equal last n, return fib cache. All right, so now what will happen is when I call this program, if I call the same fib twice in a row, it only calculates it once, right? And we can sort of prove that to ourselves by putting a print statement here. All right, and that actually showed more Fibonacci printing than I wanted. Let's see if I can. So what I could do, all right, how can I cut down? Yes, Drew. Oh, yes, they're both going to stay as -1 because I never said it. You're right. All right, so but there's still a problem. Let's before we fix this, let's comment this out for the moment. Before we fix this, let's figure out how to print this. Now we only want to print it the first time we go into the Fibonacci, right? We don't want to print out each recursive thing, right? So how do we make that happen? Well, it won't be affected by where I put print. So if I call fib5, right, that's going to call 4 and 3, and I only want to see the 5. And if I call fib7, I only want to see the 7. I only want to see the first thing. So how do I distinguish the first thing? Anybody have an idea? To be clear, right, if you want to be a programmer in your life, this is the kind of question you have to ask yourself and solve, right, fairly instantly. What, JJ? Yeah, how do you separate the first thing is the question. What do you mean by fields? Okay, I'm not completely following that, and you might be able to get that to work, but there's a simpler way. Drew, do you have an idea? Right. So what you could do, you could say have another field, right? And I could say print this one. Or it could be a field. I could have some additional field, like I could have int fibnum, right? And then I could say fm, and I would have to put a parentheses here, and I say fibnum equal 20. And then I would have to say, you know, if n equal fibnum, right? I could do that. That ought to work. fm.fibnum, sorry. Right, and now I'm seeing that fib20, and it's only getting called once. That is doing what I wanted it to do. It's kind of annoying that I had to do this extra line of code here, but I did get it to work. Can anyone think of a way of doing it without adding a field? Can anyone think of a way of doing it without adding a field? All right, so when you're thinking about recursive functions, right, what did we talk about? Some of the things that we had, tools and tips that we had with that, right? We knew we always have to have an escape clause. What is something that we often needed to have? Like think back to think back to say the one where I was adding up the sums of integers. How did that look? You remember the helper function that I had there? Right? You remember what I did there is I had a helper function. I called it with an additional argument, and that additional argument was the initial position. That was 0. You remember that? Does that give you any ideas? Oh. Logan. So, I'm sorry, say that again. Right, so you could put an initial position and keep it in every call, but we don't have a position here because this isn't an array. So what we could have is, say, Boolean print, right? And you could say if print, and then we could say false, and we could say false. And then we could have another one of these things, right? And we could say return fib n true, right? And now it works, all right? Okay, so now let's go back to what we were actually trying to do in the first place. And so we wanted to have this work, but we actually only want to do that in the case that we're printing. Okay, and then we need to save the value that we computed, right? So we need this, we need this, we need this, we need int r. Okay, and now we're going to say if print, then last n equal n, and fib cache equal fib cache equal r. Okay, and then return r. Now I'm going to move this up one, right, so that I don't see the print statement if I'm coming from the cache. All right, make sense? All right. All right, and it worked. All right, I got that cache. Now we're going to play more games with this in future classes. I feel like you need some help working through codes. Yes, Drew. Yes. So Drew's question is, why is it not confused? And the reason it's not confused is because part of the function name, as far as Java is concerned, is the list of argument types. So if if I call fib with just an int, that's going to call this function. If I call fib with an int and a Boolean, that's going to call this function. That's called overloading. Okay, so I'm going to stop here and I'm going to pass out your quizzes, and we're going to have a quiz. Yay!